The performance and longevity of your car may be jeopardized if you neglect routine engine oil changes. A healthy engine depends on the oil's ability to lubricate, cool, and clean, all of which are diminished with time. Increased friction, overheating, and the buildup of dangerous deposits are all consequences of this degradation, which can ultimately cause serious harm and expensive repairs. Number 8. Increased friction and wear due to complex oil degradation and contaminant buildup. In order to reduce friction and avoid direct metal-to-metal contact, which would otherwise result in abrasion and wear, engine oil is designed to provide a protective, lubricating coating between metal surfaces inside the engine. But as oil ages, it deteriorates chemically, mostly through oxidation, which is a heat-accelerated reaction with oxygen that produces acidic chemicals that erode metals and reduce the oil's lubricating properties. At the same time, impurities like water, metal wear particles, fuel residues, and combustion soot build up in the oil. Engine parts are worn down by soot, which acts as an abrasive, and additive depletion lessens the oil's resistance to wear. Engine oil is intended to create a protective, lubricating layer between metal surfaces inside the engine in order to minimize friction and prevent direct metal-to-metal contact, which would otherwise cause abrasion and wear. However, oxidation, a heat-accelerated reaction with oxygen that creates acidic chemicals that erode metals and lessen the oil's lubricating qualities, is the primary chemical process by which oil deteriorates with age. Simultaneously, the oil accumulates impurities such as water, metal wear particles, fuel residues, and combustion soot. Soot is an abrasive that wears down engine parts, and additive depletion reduces the oil's resistance to wear. Number 7. Engine overheating due to impaired heat transfer properties and oil circulation blockages. In addition to providing lubrication, engine oil removes heat from parts like piston tops and bearing journals that coolant cannot reach. Oil degradation causes metal surfaces to become more viscous and to develop sludge or varnish coatings over time. These deposits act as thermal insulators, trapping heat instead of releasing it. Sludge clogs oil galleries and passages, decreasing the total amount of oil circulating within the engine. Oxidized oil also loses its thermal conductivity and flowability. The engine's internal temperature rises as a result of hot spots and limited heat removal. In addition to increasing metal expansion and speeding up oil breakdown in a self-reinforcing loop, overheating can result in serious issues like bent cylinder heads, blown head gaskets, and early engine seizure. Engine parts experience thermal loads that exceed their design limitations in the absence of working oil to dissipate heat, reducing their longevity and dependability. Number 6. Sludge and varnish formation leading to oil passage blockages and oil starvation. Heat and oxygen catalyzed chemical processes transform the base oil and broken down additives into insoluble polymers and organic compounds that aggregate into varnish, a hard resinous coating that sticks to engine surfaces, and sludge, a thick, sticky gel-like substance. This sludge significantly reduces oil flow by settling in the oil pan, valve lifters, and particularly in narrow oil galleries and filter media. When oil filters become overloaded and clogged, the engine is forced to run with tainted oil, or runs the risk of having less oil delivery pressure. Rapid mechanical wear and component failure result from oil starvation in vital parts like turbocharger bearings, variable valve timing actuators, and camshaft bearings. Engine parts may be exposed to wear before proper lubrication is achieved, since gelled oil takes a lot more energy to circulate and may postpone the development of oil pressure during startup. Number 5. Reduced fuel efficiency caused by increased mechanical resistance and impaired combustion. Internal engine friction increases when lubrication degrades, necessitating greater energy to overcome mechanical resistance. For the same output power, this results in increased fuel consumption. Additionally, poor cylinder compression and inadequate fuel-air mixture combustion are caused by contaminated oil and sludge deposits, which can wear down piston rings and valve seals unevenly or cause them to lose their sealing ability. This issue is made worse by the accumulation of carbon deposits from burning damaged oil, which produces hot patches that might result in banging or pre-ignition, both of which lower combustion efficiency. In order to make up for this, the engine uses richer fuel blends, which further lowers miles per gallon and raises running expenses. Number 4. Increased harmful emissions due to inefficient combustion and oil contamination. Engine oil enters the combustion chamber and burns alongside gasoline due to worn piston rings and valve seals caused by extended oil neglect. Particulate matter and unburned hydrocarbons are released by this burning oil, increasing tailpipe emissions and contributing to air pollution. Furthermore, inefficient combustion, brought on by weakened sealing and deposits, results in higher concentrations of nitrogen oxides and carbon monoxide, which are controlled pollutants because of their negative effects on the environment and human health. Additionally, increased aldehyde and ketone content from oil breakdown results in smog-forming molecules when they burn, further degrading the quality of the air. Additionally, burning oil leftovers can clog or poison catalytic converters, which decrease pollutants, reducing their efficacy and increasing emissions. Number 3. Oil pump and filter failures from increased oil contamination and viscosity. Maintaining proper oil circulation and pressure throughout the engine depends on the oil pump. The pump has to work harder if the oil thickens as a result of sludge formation and degradation, which increases mechanical strain and speeds up pump wear. Sludge and varnish buildup in later stages clog the oil filter media, significantly lowering flow or causing the bypass valve to open, allowing unfiltered abrasive oil to circulate. An abrupt drop in oil pressure due to a blocked filter or a malfunctioning pump indicates impending engine harm if operation is continued. A catastrophic engine seizure within minutes of operation can result from rapid oil pressure reduction, which leaves moving parts vulnerable. Number 2. Progressive and irreversible engine damage, culminating in total engine failure. A damaging environment is created inside the engine by the combined effects of increased friction, overheating, lubricant loss, corrosion caused by acid, and pollutant accumulation. Camshafts and lifters develop wear and scoring. Piston rings lose their ability to seal, resulting in blow-by and oil consumption. Bearings deteriorate and either seize or develop excessive clearance, generating knocking sounds and vibrations and corrosion. From acidic chemicals erodes metal surfaces. These elements eventually lead to parts breaking or seizing because they erode the engine's mechanical integrity. If ignored for an extended period of time, this leads to abrupt or gradual catastrophic engine failure, which usually necessitates a costly overhaul or total engine replacement that is significantly more expensive than routine oil changes. Number 1. Warranty voiding and significant loss of vehicle resale value due to maintenance neglect. In order to preserve engine efficiency and dependability, manufacturers demand that recommended oil change intervals be followed. Scheduled oil changes are typically violated by warranty terms, which means that any engine damage brought on by neglecting the oil will not be covered. Owners are exposed to potentially crippling repair costs as a result. Additionally, the resale value of cars with oil neglect indicators like smoke, sludge buildup, or engine banging is significantly lower. Timely oil changes with proper documentation maintain both mechanical condition and resale value. In summary, neglecting engine oil changes leads to progressive deterioration. From minor wear to overheating, sludge formation, severe engine damage, and ultimately, total engine failure, incurring significant repair costs and vehicle downtime. Regular oil changes are essential to keep the engine lubricated, cool, clean, and running efficiently. If you liked our video, please hit the like button and subscribe to our YouTube channel.